Alright, so we took a look at what covalent bonds were. So now in this video we're going to take a look at how to draw covalent bonds. So remember in ionic bonds, when we were drawing them, we had our two Lewis dot diagrams and we had an arrow showing that the metal was giving an electron to the non-metal. Now for this one, they're not going to be giving and taking, but they're going to be sharing together. And it's a bond between two non-metals. So I'm going to start with, I would say, probably the simplest molecule, which would be a molecule of H2. And that is just two hydrogens that are bonded together. Now remember, in the periodic table, hydrogen is in group 1. So it has one valence electron. And we can see here that this one has one and this one has one. And remember that hydrogen also only has one shell of electrons. So it only needs to fill that first shell, and therefore it only needs 2 electrons to be stable. So if this one has one and this one has one, instead of one giving to the other one, we can satisfy both of them, and they're going to share their 2 electrons together. So now this hydrogen has 1, 2 electrons, and this hydrogen has 1, 2 electrons. And we can draw that with just a line in between them like that. So this is how we would draw a covalent bond for H2. And this line here represents a single bond. So hydrogen has 1, 2, and this hydrogen has 1, 2. So it's good to go. Now let's take a look at another example. I'm going to take another molecule, Cl2, which is just 2 chlorine molecules. So if I have Cl here and Cl here, and if you look in the periodic table, chlorine is in group 17, so it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now chlorine, because it's further down in the periodic table, it needs 8 valence electrons for it to be stable. And right now this one has 7, and this one has 7, so they each need 1 more electron. So what happens is they are going to share those 2 electrons. So now chlorine has 1, 2, 3, 4, 5, 6, 7, 8, and this chlorine has 1, 2, 3, 4, 5, 6, 7, 8. And we can also draw that like that with just a line in between, and then we just put the rest of the dots around it. We're going to take a look at a few more examples here. Alright, so another example that we can do is oxygen, which is O2. So oxygen is in group 16, so it has 6 valence electrons. Now that means that it's going to need 2 valence electrons to get to 8 to be stable. So what's going to happen is oxygen is going to share 2 sets of electrons with each other. And now it has 1, 2, 3, 4, 5, 6, 7, 8. And this one also has 1, 2, 3, 4, 5, 6, 7, 8. So this one also works out. And we can draw it with 2 lines in the middle, and then we just put the other dots around it. Now because we have 2 lines here, this is what is called a double bond. And if we look at one more example, let's take a look at nitrogen, which is N2. Nitrogen is in group 5, so it has 1, 2, 3, 4, 5 valence electrons. So it's going to need 3 more to be stable. So I'm sure that you might be able to guess this already. Because it needs 3 more, it's going to share 3 sets of its electrons. And now nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's also satisfied. And you might be able to guess as well that the way we draw the molecule is just by putting 3 lines in between with the remaining electrons there. And this one here is called a triple bond. So what if we have molecules with different elements in it? So right now we've just looked at ones that have just been hydrogen, chlorine, oxygen, nitrogen. What happens when we mix different elements in there? Let's take a look. All right, so what if we take HCl? So going back, we can remember that hydrogen is in group 1. It has 1 valence electron. Chlorine is in group 17. So it has 7 valence electrons. So they each only need 1 more electron. Remember, hydrogen only needs 2 to be stable. So what's going to happen is they're just going to share this 1 pair of electrons, and we get a molecule that looks like that. So hydrogen has 1, 2, and chlorine has 1, 2, 3, 4, 5, 6, 7, 8. So they're both happy like that. Now we could also consider H2O. So hydrogens, they only need 1 more electron each, but the oxygen needs 2 more electrons. So what's going to happen is we're going to have our oxygen here with its 6 valence electrons, and our hydrogens here with 1 valence electron each. And now this hydrogen is going to share its electron here with oxygen, and this hydrogen is going to share its electron with hydrogen. So these hydrogens have 1, 2, and 1, 2, so they're both happy. And our oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So the way that we can draw that is something that looks like this. And we'll take a look at one more complex example. All right, so the last one I'm going to talk about is CH4. Now carbon is in group 14, so it has 4 valence electrons. 1, 2, 3, 4. So it needs to make 4 different bonds to be stable. Well, it needs 4 more electrons to be stable. Thankfully, we have 4 hydrogens that can each share 1 electron. So if we just place them around the carbons and give them their valence electron, now carbon can bond with all 4 of these hydrogens. 1, 2, 3, and 4. And now each of the hydrogens is happy because it has 2 electrons now. And the carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons. And the way that we can draw that is by putting our C in the middle with the H's all around it with a single dash in between. So I hope this helps a bit for how to draw covalent bonds. That's going to be that's going to be your assignment for this topic. And I'm going to post another video as well that might help a bit more with how to draw covalent bonds and the Lewis dot structures. But that's it for now. So have a good day, guys. See ya.